So, do you remember which we did yesterday? We did like a limit on both sides. Limit as x approaches. And so do that one. Is this 8 or is it? Yeah.
Okay, so questions for homework.
You do number 9.
What a number 9
Yeah.
says.
Choose. H. Just like that.
I don't know, but I can't find my questions. Oh, it is. Number 9. Oh, it's easy. I think.
Let's remember. Oh,
Number 9 just multiply this by 1 plus x over 1 plus x. So it'll be 1 over square root 1 plus x, 1 minus 1 plus x over x when limit x approaches 0. And you can multiply by conjugate. Just the top. So you get 1 minus 1 minus x, right? Over square root 1 plus x, 1 plus 1 plus x over 1 over x. So this x cancel out. That's going to give you negative 1. You plug in 0, it's going to be negative 1 half.
Can you zoom in on the?
Oh, I'm so sorry. The other one.
So in the first step, when you multiply it by square root x plus or 1 plus x over square root 1 plus x.
No, I have a combined fractions first. So that's square root 1 plus x of 1 minus square root 1 plus x. And I multiply the conjugate for the top. I mean, that's how I approach it. You might approach it differently. Some people approach it differently. So
Did you multiply? You multiplied 1 over.
what?
Oh no, I see.
Oh, this is multiplication.
Second step, when you multiply by the conjugate, or you multiply the top.
Yeah, well, it doesn't matter just the top and bottom. It's top is fine because that's 1. Anything multiplied by 1 is fine. You're not changing the fractions.
Right. But how do you get rid of the x on the bottom?
Because that's divided by x, so it's times 1 over x. So if your top part simplify it down to 1 minus 1 minus x, and 1 minus 1 is 0, negative x cancel with the bottom x, and that's going to be negative 1. You look like you lost.
But maybe not.
This multiply conjugate is 1 minus 1 plus x, right? 1 minus 1 minus x. That's equal to negative x, right? So if this part is negative x, if we divide it by x, that means stems in times 1 over x. That x and x cancel out. I just write down 1 over x here. So because this is x here, and that x cancel out numerator x. This one's a negative infinity. This one, I don't know if you guys got negative infinity. Yeah? Okay. That's a one. All this question are good question. You are probably gonna see some type of question like that.
What was the answer for 6?
6. I don't know. Limits x approach to 5 of x minus 5. X squared plus 5x plus 25 over negative x minus 5. And if you average 5, I think it's negative 75.
That's what I got. It's weird.
It doesn't matter. Number is number. All those questions are good question. Now I show that even like a C, if you type in this on Desmos, is super cool. I don't know if you've seen that before. I'll show you. Type in a decimal. So A is some type of number, right? So we don't know what a number is. So x squared minus a squared over x minus a. So I'm going to type in, what was it? X squared minus a squared parentheses divided by what? X over minus a. Okay, so show a. That is there is a 8a, so it'll be 8 comma a. So this is the point. So somehow that there is open circle here, right? There's an open circle here. I don't know where they are. A is 1, so it's probably here. See that open circle? See that open circle? But the open circle is a move according it, right? So we must find out what it is. And hopefully you can wait. Hold on a second.
Would it be the report?
8a. Yeah, that you're right. So yeah, so you want to find out, like, because that hole is constantly moving too. So the hole somewhere here, eventually that. So you want to go back. So that eventually that coordinate gonna fill in that hole, which is like, it's very very cool, very very cool question. So ace 4, I think that should be the answer, right? That's super cool, that because that hole is constantly moving along the line, and then point is constantly moving as well, but there's only one time it met, which is pretty awesome questions.
Can you show how you do a D?
D, okay, yeah, of course. D is another question I thought was really good, but first of all, you had to understand this domain right here. So x minus 2 greater than 1. That means x minus 2 greater than 1. X greater than 3. And this is x minus 2 less than negative 1. And x is less than plus 2, so is 1. So the thing is that there is a less than, this is a between 1 to 3. This function could be less than 1 or could be greater than 3. So what interesting thing is, this question should write down as this will be x squared plus bx plus c when x is less than 1. We're going to write in descending order or according to the domain. X plus 1 from 1 less than x less than 3. X plus 1, right? And the next one's going to be x squared plus bx plus c when x is greater than 3. So obviously there was a break between 2 points, right? So it'll be limits x approach to 1 from the left. Which equation I'm going to plug in?
X squared plus bx plus c.
Yeah, so and equal to limits as x approach to 1 on the positive side of x plus 1. If I plug in 1 here, that's going to give you a 1 plus b plus c, I think, equal to 2. B plus c is equal to what? 1. Is that okay? Now I'm going to do a limits as x approach to 1 from the positive side. Now this one's going to be x plus 1 is equal to the limits as x approach to oh sorry, no, one. We already finished with 1. What's the next breaking point? 3. And this is a 3 from the left side and 3 from the positive side. So it'll be x squared plus bx plus c. Now if I approach 3, that's equal to 4, I think. 9 plus 3b plus c. That's going to be negative 5 equal to 3b plus c. Is that okay? I think. I'm changing this negative b, negative c equal to negative 1. So that's 2b is equal to negative 6. B is equal to negative 3. Am I doing okay?
Yeah, it is always.
And then negative 3 plus c is equal to 1. C is equal to 4. Okay. Yeah, this is also beautiful when you plug into the decimals. Because I showed you guys last thing. Okay, let's try it. X squared plus I show bx plus c. And what's my restriction? I forgot. My restriction is what? What's absolute value, right? Greater than 1? Huh?
Yes.
And if you show up like that, it's gonna be like this. So this thing is like constant moving. And we're gonna do x plus 1, I think. Raised. And that's gonna be between what? 1 less than x less than 3. And you see that there's only one time, because we're moving both v at same time, but there's only one possible they can be. B we got negative 3, I believe. Is that right?
Yeah.
And C we got what? 4. And that this line was connected. And super awesome because math works right here. Austin, do you do homework? That smile. Your test is on Monday. About to whoop your ass second time. No?
I'm jinx myself.
Daniel's like, I'm gonna be clutch. Better than what?
Triangles. I don't like triangles.
You don't like triangles?
I mean, right.
Oh, that's true. Then you got law of sine, law of cosine. Okay, so this is a very beautiful done. Cool questions. It's a couple FRQ just let you practice some FRQ questions. But I'm going to talk about today's stuff because I put a lot of question is limit approach infinity. So, okay, let's start with one question first. I'm gonna ask you. I asked this to you guys last year. It was f of x equal to cosine of x minus 1 and 2 cosine square of x. I forgot what is it. 2 cosine square of x minus cosine of x minus 1. I say, hey, can you find removable discontinuity? And I find non-removable discontinuity. So you got those two questions here. I want you guys try to find that. I don't know if you remember how to find it. Remove discontinuity is something that What is that? That's a non-removable or removable? That's a removable or non-removable. Well, yeah, but you also had to set it equal to 0. Yeah, solve for x. So x is what? Okay, good. But there's a coordinate though. Hole is a coordinate. So how do you find the y of that coordinate? Plug it back in. Plug it back in the original equation, right? So if you take this, you can factor this. What was the factor? 2 cosine of x. Cosine of x. This is a plus 1, right? This is minus 1, I believe. This is minus 1. And this is a plus 1, I believe. And this will cancel out. And this will become 1. So f of x is, after you modify, it's going to look like this. So you can plug in, well, we know cosine of x minus 1 equal to 0. X is equal to 0, I believe. Then you can plug in f of 0 is equal to 1 over 2 cosine of 0 plus 1. That's equal to 1 over 2 plus 1. 1 over 3. So 0 and 1 over 3 is the removable discontinuity.
Did you get the cosine x?
Because whatever cancel factor is my whole. Whole is a removable discontinuity. Do you guys remember this?
Then non-removable will be x equals 2 pi over 3.
Yep, x is equal to what?
2 pi over 3, 4 pi.
If I want to find out the whole thing is 2m pi actually, because it's everywhere. Now this is only this could be everywhere as well. So it's 0. It could be like 0 plus 2m pi.
Yeah.
Yeah, that could be like 0 plus 2m pi, but everything is going to be a little bit different. Maybe it's all 1 over third, huh? Because it's 2m pi, that's always 1. So it could be like this for all coordinates. All coordinates. Because if I plug in 2 pi, it should result the same thing. So it's pretty much consistent. If you really want to find out, I can just give you one. I'll give you a domain. This one's okay? Not too bad, right? Jared?
How'd you get 1/3?
I plug in back in the original equation after the simplifications. I'll plug in 0 into here. Because that's a remaining equation, right? So you still can plug in to get evaluation.
There, right?
Yeah. So 0 and 1/3 is equivalent. So this is like a crash course of limits. Now today we're going to go over a crash course of infinite limits. What is infinite limits, right? Okay, how much time I have? 25 minutes, good. Okay, infinite limits. In last year at pre-cal or in my calculus class, we talk about how to find horizontal asymptote and how to find vertical asymptote. So horizontal asymptote. In pre-cal, it's different definition. In calculus, this is final definition. Is x approach to infinity of f of x is equal to L. Limit x approach to negative infinity of f of x is equal to another L, which is constant here. So that's how you find horizontal asymptote. So if you want to find horizontal asymptote, limit x approaching infinity. Now let's recall something, how to find vertical asymptote. Vertical. Vertical asymptote is denominator equal to 0, right? Is denominator equal to 0? Actually equal to 0, sorry. And that's how you find a vertical asymptote. Horizontal asymptote is this. Now, here is you're probably gonna learn quick because most of them they already learned this, so I'm just gonna speed run this. Okay. I can give you 3 different type of function. I'll just give you an easy one, so. Okay. And this is a second type of function. And the last type of function. So last type of function is f of x is equal to 5x to the third minus 1 over 2x squared plus 1. So there's 3 type of functions here. Where's the horizontal asymptote? Do you guys remember how to find horizontal asymptote? Actually, I'm going to ask Jared first because do you remember how to find?
0 for the second one fits, and then take up 2 division for the last one.
Okay. Well, you're right about first 2, which is good. Hopefully, Rebuff, do you remember this? Okay. So the best thing is divide the highest degree of denominator. So if I divide by highest degree of denominator, I'm just going to approach infinity. So the first one is going to be limit x approach infinity of 2x squared plus 1 over 6x to the 3 plus 3x. The highest degree of denominator is this. Am I going too fast? We probably should remember this. Limit x approaching infinity, this one is going to be 2 over x. If I simplify it down to 1 over x cubed over 6 plus 3 over x cubed. Now, what happened when limit x approach infinity at, let's say, a number over x to any power is equal to what? 0. Good, because this part is going to give me 0, this part is going to be 0, this part is 0, because the bottom is what? X. If we go to infinity, 2 over infinity, that is essentially going to be 0. So therefore, the first case is limit x approach infinity. On this particular case, 2 over x minus 1 over x cubed over 6 plus 3 over x cubed is all equal to 0. So therefore, your horizontal asymptote is at 0, as opposed to somewhere else. Jared, you understand? Okay. I'm going to do the same thing on the second one. So limit x approach infinity of 4x squared minus 1 over 5x squared minus 2x. So you still divide it by x squared. So that's going to be 4 over 1 over x squared, 5 minus 2 over x. Now, as you see, what is this going to if we reach infinity? What is that going to? 0. This part is going to go 0. So the answer is 4 over 5. And that's why you know it's 4 over 5. Now, I'm explaining you a reason, Jared. You might just remember it. Just take a ratio. But this is the reason why. And if I divide by highest degree of denominator, I'm not breaking any math. Last one. I'm gonna do limits x approach to infinity. 5x cubed minus 1 over 2x squared plus 1. Again, the highest root denominator is going to be x squared. So I'm going to divide everything by x squared. So that's equal to limit x approach to infinity of 5x minus 1 over x over 2 plus 1 over x squared. And that's going to be infinity because the numerator is 5x. That becomes infinity. If it's infinity, there is no horizontal asymptote. The reason why it's no horizontal asymptote because the function is going up. You don't plateau into a value. So there's no horizontal asymptote. Now, obviously, you're going to ask me, how about negative infinity? Well, in this case, you don't really need it. It's going to be the same whether you plug in positive infinity or negative infinity. But I'm going to give you 3 different cases where they might make a big difference. And for all my AB students, they know this very well. And its only person is Jared. So we're going to try to explain you 3 different cases that the horizontal asymptote, it doesn't matter. So those of you guys, you should start thinking about it. First one is going to be square root of 9x squared minus 1 over or plus 6 over 3x. No, actually, I'm not doing 3. 4x minus 3. Now, not only want you to find a horizontal asymptote, I want you to find all asymptote. All asymptote. Okay. Jerry, don't know how to do this yet. Let's say find all asymptote. How do I find all asymptote? What is first type of asymptote is easier to find? Vertical. So vertical. Is 4x minus 3 equal to 0, x equal to 3 over 4. Cake. Not hard. Now, I'm going to find horizontal asymptote. Now, most of you guys, you're still lost, even I explained last year. So it's going to be 9x squared minus 1 plus 6 over 4x minus 3. And I'm going to say limits x approach infinity. So what happened is, what's the highest degree on denominator? X. So I'm going to divide this by x and x. Jared, are you doing okay? Now, inside a radical, you're supposed to divide it by what? Well, Jared, do you understand why it's x squared instead of x? Because you were talking about inside a radical, so that should be x squared. Divided by x squared. All right, done. So it's going to be...
Shouldn't the 6 just be x since it's not inside the radical?
Yeah, I keep on making this a mistake. Thank you. So 9 minus 1 over x squared plus 6 over x over 4 minus 3 over x. So now limit x approaching infinity. You say, well, 1 over x squared is easy. That's going to be 0. That's going to be square root of 9 plus 0 over 4. Square root of 9 is 3, so it's 3 over 4. And that's your... That's your horizontal asymptote. You got it? Now there's another one, which is what happened when limit x approach negative infinity as opposed to positive infinity. See, this is different. Now, the same thing, 9x squared minus 1 plus 6 all over 4x over x minus 3 over x. Whoops. I'm going to do that later. I'm going to divide it by x. Now, inside the radical is going to be something changed, though. Because square root x squared, what does this graph look like? Jared, do you know what this graph look like?
Sure.
Should type in the decimals.
Should it just be like y equals x, but no negatives?
Type in.
Easier,
Yeah, type in. This is very interesting. I have seen this question on SAT before. It's like, which following graph does this one look like? Most people pick y equal to x. What do you say?
Like absolute.
Yeah. So that means on the left side is negative x. So I hear when you divide this, kind of be careful. This is a negative outside and square root x squared. And that's where to think about it, because a negative is going to be outside. So therefore, the output of here is going to be negative 3 over 4. Some people just memorize says there was a positive 3 over 4, and they're probably going to have it negative 3 over 4. But the reason why they got negative 3 there is because that particular part, I'm going to divide it by negative square root of x squared. Because I'm going to the left side. On the left side, I'm actually divided by negative x rather than positive x. All other one doesn't matter because I can divide by negative x on all the term. That's not changing it. Well, 4, but yeah. The 4 doesn't matter because, oh, that 4 does matter if you have divided by negative, but you want to, 1 is negative. So their answer is going to be negative 3 over 4. So there was always a second one if you have absolute, if you have radical. Got it? Okay, so there are 2 other cases I want to talk about. 12 minutes, good. This is also another function. I love this question on SAT, AP exam. Is 3e to the x minus 4 over 6 minus 2e to the x. Yeah. How many asymptote are there? Actually, there were 3. Again, I'm going to start with the vertical asymptote. So 6 minus 2e to the x is equal to 0. 6 2e to the x. 3 equal to e to the x. Natural log of 3 equal to x. So that's first vertical asymptote. Fairly straight, fairly forward. Horizontal asymptote. They were 2. First one's going to be limit x approach to infinity of 3e to the x minus 4 over 6 minus 2e to the x. I'm reaching infinity. What's the best way to do this? But there's a couple ways to do this. What?
You just first divide by the degree.
Well, divided by degree, that doesn't really help. But divided by what? E to the x is a good choice. But I actually like this way because the problem is...
That's enough. Maybe I said
Yeah, so that's going to be limit x approach to infinity. That's 3 minus 4 over e to the x over 6 over e to the x minus 2. Now, this will go to 0. This is going to go 0, right? So it's going to be equal to negative 3 over 2. And that's final answer. Because bottom is negative 2. Top is 3. So it'll be negative 3 over 2. Am I done? There's one more. What do we talk about? Now, how do I get this one though?
you don't divide by e to the.
Yeah, you don't. Why?
Because if you plug straight in, it'll be 3 over.
Yeah.
And then-
So that's why on the Algebra 1 review sheet, Algebra 2 review sheet, I say you guys have to know this graph. And I keep on saying from the first day, nobody pay attention to me. I said it's going to be on multiple tests, even though it's not on the first test. This is the e to the x graph. There's asymptote here. And that's 1. Well, 0, 1. But if I go to negative infinity, so limits x approach to negative infinity of e to the x, that's going to be e to the negative infinity. That's equal to 0 according to the graph. So then it's anything e to the x is going to be 0, so it's going to be negative 4 over 6. That's equal to negative 2 over 3. So exactly opposite than the other one. So you got a natural log of 3 for vertical asymptote, and you got negative 3 over 2 for horizontal asymptote, and negative 2 over 3. Jerry, okay? Yeah, because e to the negative infinity is going to be 0. So 3 times 0 is going to be 0. And for those of you guys in AB, you guys should know this blindfolded. It's the only thing I need to explain to Jared. And some of you guys might just need to review a little bit. Can I give you one more example that has 2 horizontal asymptotes? So we give you 3 examples of 2 horizontal asymptotes. First one's with radical. Second one with e to the x. And there's one more. I like this one personally. Is absolute value x 3x minus 4. Something like that, right? So that is actually, this one is never been tested on AP exam. And I'm always very disappointed why they never asked this question.
What about logarithm? Would that be one? Would that be another like case?
I actually don't know, but you should research it.
Yeah, logarithm, because it's going back. Well,
Yet logarithm would be easier to ask vertical asymptote. I don't know about horizontal. Yeah, because when they go to negative, when they go to a certain value, it can go to negative infinity. So how many asymptote this one has?
4. I mean 5.
How'd you get 5?
Wait, okay, because that's absolute value, so it's like the negative x, and the x and the negative infinity plus the vertical asymptote.
So you say it's 5. But I say it's 3. I hate to break to you, but I say it's 3. Just because I don't have a lot of time, I have 6 minutes to explain this part. It's actually vertical asymptote is super easy. So 4 over 3, anybody should be able to find vertical asymptote right now. Now, if I try to reach this, right? Hopefully you guys already see what I'm trying to go with it. X approach infinity up to, well, that's no longer absolute value x. If I go to positive infinity, that's just 2x over 3x minus 4. So easily divide by x on top and bottom, that's going to give you 2 over 3. That is the first one. Now, if I say limit x approach to negative infinity, that also doesn't mean 2x. It's actually negative 2x over 3x minus 4 because I approach negative infinity. So therefore, it's going to be negative 2 there. So absolute value and radical, they have usually 2. And they are usually positive and negative to each other. Jared, am I going too fast?
We get negative 2x for negative 50 if it's.
Because I'm going negative infinity. So my absolute value x, it's going to choose negative x rather than positive x. Remember?
What's the absolute value? Shouldn't it go to positive anyway?
Yeah, so this is x, this is a negative x. So I'm going left side, I'm choosing negative x. You got it?
Not really.
Okay, Daniel, can you explain to him?
Yeah. So if you're on the negative then the function
I guess. Maybe it makes sense. Maybe.
Graphically, you have to understand absolute value x is two function. It's a piecewise function. If I go to negative infinity,
negative side.
But shouldn't negative infinity and positive infinity for x be the same as well since it's the absolute value?
so yeah, so the way easier way to think about it is, I see what you're saying. I see what you're saying. Hold on a second. So it would be like easier to do this is like instead of reach negative infinity, instead of this, right? Absolute value of 2x. I think I see what you're saying. I think I shortened one step. So it can say it's limit x approach infinity at negative 2x over 3x minus 4. So if I'm reaching negative infinity, I'm going to choose the negative on the top.
And here too, just like we were doing earlier. Limit as x approaches infinity of like absolute value of x minus 1 divided by x positive. Do you remember when we did that?
Yeah.
Then if it was negative, you'd make that. That was.
And I'm also going to show you here. So this is a function, right? What is it? What is it? 2x minus 3 or what? 3x minus 4. So it looks like this. It has a asymptote 4/3, right? And when we choose the negative infinity, that, you know, maybe that tells you a little bit better. Negative 2x over 3x minus 4. Do you see that when it go negative infinity, after this part, it start matching? Do you see that? That's only start at 0, which is interesting. I didn't know that. It start at 0. After that, it start matching. After 0, not before 0. That's pretty cool. I didn't know that. Okay, so yeah. Did that help you?
I think I get it.
See that after the 0, well, after less than 0, it's going to be follow the same exactly as negative 2x over 3x minus 4. Does that make sense? And what's cool is x equal to y equal to 2/3. Y equal to 2/3 is the asymptote, like right here, right? And that's y equal to negative 2/3. And that's another asymptote. So, and you're going to say, why is this point touch? It never says they cannot touch in the middle. It only talk about infinity because that's definition of horizontal asymptote is rich infinity rather than somewhere in the middle range. And I gave a really good analogy last year. I told people like horizontal asymptote is like vertical asymptote is like for sure gay. Like you look at a person that he's gay for sure, but like a horizontal asymptote is like I'm not gay yet, I'm half gay. Like I'm gonna experiment what it's like to be a opposite sex, and then after once they say, oh okay, I'm gay.
It's graph bisexual.
Yeah, is this graph bisexual? that's my thumbnail. Is this graph bisexual? Best ever.
Negative x on the bottom instead of the top.
Huh?
Or negative infinity.
What'd you say?
Like if you plug in negative infinity for x, you just make it 2 on the top. positive on top, negative on bottom?
I don't know. Try it. Try it. Try it. Come, I don't know what you're saying, but you can try it. Try to type it. Try it. Experiment. That's the only thing is an experiment. What's up?
Two questions, one
Sure.
past homework. For this one, the ABC thing, are you allowed to factor out the diagonals while it's in division, or do you have to switch in multiplication first?
For me, I switch to multiplication and just multiply everything together and just do exponent rules.
Okay.
I mean, that's probably the easiest thing. I don't think about factoring when I deal with like something like this. I don't deal about factoring. But technically, each thing are factored to each other. So 32 is a factor, a cubed is a factor, d squared is a factor. So technically, they are like that. But definitely just use exponent rules, and that's easier to deal with. I feel like.
And then I had a question on this one. Is it supposed to be an a plus bi form?
Yes, and I.
'Cause you'd get a different answer if you formatted it first.
Okay, so let's talk about
That's
that.
what I was wondering.
No, that's a good question. So I'm gonna turn off the stream here. Okay, so I say